Okay, Ramchandra. So can you please introduce yourself?
Yes, my name is Ramchandra Srikanth and I am from Andhra Pradesh, Kakinada. I did my diploma in mechanical engineering. Then I completed my BTech in circuit engineering college in the stream of mechanical engineering. After that, I joined TCS as a system engineer and currently working in TCS.
Okay, now I want you to, this is your introduction, right?
Yes, sir.
Did you had to like think about it or something like that? No, it's your own details, right?
Yes, sir.
Yeah, now can you try to be a little more confident this time? I'm going to ask you this again, and I want you to
Yes,
be
sir.
little confident and little loud as well, okay? Yeah, it should
Okay,
feel
sir.
like you have done your diploma and BTech. Be little confident. Okay, Vamsik. So, can you please introduce yourself?
Yes, my name is Ramchandra Srikanth and I am from Andhra Pradesh, Kakinada. I did my schooling in Andhra Pradesh only. Then I joined diploma and I completed diploma in the stream of mechanical engineering in 2017. Then I joined BTech as lateral entry in the Circuit Engineering College and I completed BTech in 2020 uh, in the stream of mechanical engineering only. Then I joined TCS as a system engineer and currently I'm working in TCS.
Okay, so you are working in TCS in IT job, and there are people earning a lot. So why do you want to join BRC? Why do you want to come
Actually,
back to mechanical?
Actually, I joined TCS. I got TCS offer while I'm in college in fourth year as a campus placement. I have interested in mechanical engineering since then. So actually, when I passed out, the lockdown happened, and I joined TCS because I have that opportunity in my hand, and I'm preparing for this PSUs like which I am interested to join more technically. I want to pursue my career in technical in the core stream of mechanical engineering. So,
Yeah, that's a good answer. Very good. I mean, you seem prepared. Really nice. Okay, Vamsi. So, what are the subjects you have command on?
yes. Strength of materials, thermodynamics, heat transfer, and fluid mechanics.
Okay. What are modes of heat transfer, and can you please explain their principle behind them?
There are three kinds of heat transfer. One is conduction, convection, and radiation. Conduction is like in solids, the molecules are in vibration state, so the heat will be transferred from due to due to that vibration. And conduction plus there is movement of bulk, movement of fluid. It is called as convection mode of heat transfer. And the radiation is like whenever there is temperature difference between due to the electromagnetic waves, the heat transfer will be taking place. That is a kind of radiation.
Correct. So, here is a problem for you and everyone else as well. Tejashwar, Mahendra, you also try to solve. Uh, महेंद्रा, लास्ट ईयर मैंने कुछ सन के रिलेटेड प्रॉब्लम सॉल्व करवाया था क्या आपसे?
No, sir.
नो, ओके, ग्रेट. या, सो दिस इज अ गुड प्रॉब्लम. Vamsi, here is your problem. This is for all of you, okay? Or what
Yes,
I'll
sir.
do is I'll just paste the link in the group, and then till that I'll ask you something else. If anyone wants to join in, they can. Okay, yeah, great. So, Vamsi, tell me one thing. What is turbulent flow?
Uh, when if the Reynolds number actually there are two kinds of flow in fluid. One is laminar flow and turbulent flow. If the Reynolds number is very high, there is some molecules transfer diffusion will happen very fastly inside the fluid. That flow is called turbulent flow, sir.
Okay, and how is it exactly different from?
In laminar flow, the flow happen layer by layer. The fluid flow layer by layer. But in turbulent flow, the fluid like disperse from one place to another place. It will not flow in layer by layer form.
Correct. So which one of the flow essentially demands higher energy, more energy?
Turbulence flow causes more losses.
Okay. So is turbulent flow always bad?
No, sir. It's kind of based on the application. Uh, it will be useful.
Okay, great. So can you comment about turbulent flow in terms of convection?
In terms of convection, if the turbulent flow is very more, which means it is forced convection, we can say the heat transfer in it will be there in that region will be forced convection. So more amount of heat can be taken from the solid which we place in that area.
Correct. So can you give me some real life application of this scenario?
uh, Fins in a motorcycle.
We have
And
fins for like do fins there essentially serve some another purpose?
like it like takes the energy from the engine, which from the engine in order to not get very more heat.
Is energy the correct word here? I mean, but still, it takes heat actually.
Like heat energy,
Yeah.
energy means heat energy, sir.
Okay, so we have fins there. I mean, do we have fins to essentially make the flow turbulent, or fins serve some another purpose as well?
No, we not keep fins for turbulence flow. As the as the bike moves little more than like 30 to 40 kilometers per hour speed,
Mm-hmm.
even if the fins are not there also, the flow is turbulent flow over the engine.
Okay, my question is why do we have fins?
Fins is like to increase the surface area, not to so can I share my screen, sir? I
Yes,
can write
please.
and show you.
Okay.
It's showing disabled
Okay,
screen sharing. Can
I'll
you and
yeah. Share whiteboard, share screen. Yeah, please.
sir, the
So don't go into the whole formulas and all.
yes,
Okay, just draw the diagram and that
um,
should be all.
yes, I'm saying that this is the heat transfer. So essentially, if we increase the surface area, then the heat transfer will be more. So we try to increase the surface area around the engine in order to transmit more heat energy from the engine to surroundings.
Correct.
That's why we use fins.
Okay, now given you have a whiteboard, let's go into little mechanic side. Okay.
Okay, so
Okay. So can you please erase this? Thank you. Now draw a wedge at angle theta.
sir,
Great. It's a smooth wedge, angle theta. Okay, everyone try to attempt this question. Okay, it's not only for him that we are talking about. Great. Now keep a spring at the lowermost point actually, and there is a mass m. Lowermost means it's going up. No, no, not like that. It's going along the angle theta. Up. It's going along the wedge.
lowermost in the sense here only, no, sir.
Okay, let me share the screen. Okay.
Okay, sir.
अरे यार ये जूम का व्हाइट बोर्ड का कुछ इश्यू है क्या? It's just saying loading. Okay, let me open snipping tool. Maybe that will work. Okay, yeah, great. So share snipping tool. Okay, yeah. Is it visible?
Yes, sir.
Wait. Now it must be visible. Yes.
I'm able to see
Ha
snip
ha.
tool. Yes,
Now,
sir.
yeah. Now, so we have this wedge at angle theta, and I have
Yes,
a
sir.
spring like this, okay, and there is this mass m.
Okay, okay, sir. I will draw. Yes, sir.
Okay, yeah. Now this mass m is in equilibrium. So
Okay,
can you
sir.
comment about this spring, its position or its deflection or something like that?
Yes, sir. I will show. I will
Yeah,
share my
I'll now
screen,
stop
sir.
share with. Yeah. By the way, which tool is this? Which app is this that you are using?
One note, sir.
OneNote. Okay, correct.
This is mass.
Yes.
Uh, if you take a free body diagram of this mass,
Don't go too much
this
detail. Okay, I know you just try to get into answer. We don't have that kind of time actually.
yes, sir. Yes, sir. Just
Okay,
mg
if you want
cos
to do
theta.
that, you can. But I'll be happy if you go
Yes,
little ahead.
direct form. Yes, like instantly, I cannot say I need to derive.
You can. I'm not denying that. You can, please.
So this is like say if we mg sin theta will be equals to that spring stiffness into the deflection.
Okay,
Mg
great.
sin theta by x is this is
Yes, I go. Okay, great, great.
sorry,
You are
this is
right.
the deflection.
You are right. You are right.
Yes, sir.
So now my next question is, let's say there is another scenario in which the spring is unstretched.
Unstretched. Okay.
Yes, and mass m, obviously it will need some force, so I am holding it with my hand.
Okay, sir.
Okay, and now I let the hand go. I let
Okay,
the
sir.
mass go. What will happen?
Uh, eh, then the vibration will start, sir.
Yes, so I want you to tell me what will happen with the mass, how will it go? Well, what will happen? That's my very general question.
Then kinetic energy, the potential energy is equals to kinetic energy. In that we can solve the deflection.
Okay, so can you give me some expression where will be the bottommost point of my mass m? So you are still not talking very precisely actually. Vibration is correct.
Yes, sir.
Okay,
Yes, sir.
I'll tell you the answer. So the mass will go down and it will come up, something like that. Okay, first it will go down, right? So let's
Yes,
focus
sir.
on that
It will go
particular.
down.
Correct. Let's
It
focus
will
on
go
that.
down and again. Yes,
Yes,
sir.
first focus on that journey only going down. Okay, so it will reach some
Okay, sir.
lowermost point, right?
Yes, sir.
Yeah. What will be the lowermost point? That x, let's say. Will it be same mg sin theta by k?
Uh, no, sir. No, sir. In this case, it will not. This will not follow.
Why?
Uh, because we are loading you are leaving instantly. So in
Okay.
this case, we need to convert potential energy is equals to kinetic energy. Then we can solve. Sir.
Okay, great.
I- in
That's a correct answer. Now I want you to draw a velocity versus displacement graph, v versus x graph of that mass m.
velocity was uh, initially.
I don't really mind your curvature and those things, but can you draw an indicative
Yes, sir.
diagram?
Yes, sir. Velocity versus time or x, sir.
Sorry, x.
uh, I am taking uh, the unstretched position as x is equals to 0.
Okay, great.
If
Obviously, huh?
I take that, when you release the velocity, start from here. No, no, no. From 0 to it will increase and decrease. It will become 0, and now it will increase
Okay,
more speedily.
yeah. Can you please repeat what did you just say?
When you release from hand, uh, the initially it was 0, then
Hmm.
it increases, and due to the spring force, it decreases. And again, when the spring transmits the energy to mass, it
Okay.
increases more, like the velocity increases more fastly. Then it accelerates more fastly compared to the down, and again it will continue if there are no friction losses.
Okay, so the velocity peak that we are getting here, the topmost point of those kind of the triangle that you draw,
Yes, sir.
will they be at different height?
Yes, sir. It will be different, sir.
Okay, why they will be
One,
different height?
one, one, one minute, sir. It will be different. Yes, sir. It will be different because initially we are dropping from no height, the sense the distance between the spring and the mass is zero. Like the one you said, it depends on from where you drop the mass. Sir, what I'm saying is, if this is the wedge and this is the mass, this is the spring, and if you leave from here,
No, we are not
then
reliving like that. We are, as I said, we are
mm,
reliving at zero deflection point.
zero deflection point. Then first it compresses, sir. That compression takes slowly because there is opposite force also, like the spring force is opposing this one, but when releasing this force is transmitting energy, so it move.
So my question is that peaks of velocity, Vmax you can get.
Yes, sir.
Will that be same or
It
different in
will
each
be
cycle?
it same, sir, because there is no energy we are giving to it.
Correct. It will be same.
Like
That's what I was trying to get.
yes, sir, it will be same because
It,
we are not giving any external energy to it.
correct, correct. Okay. Yeah, you can maybe stop sharing now. Okay, Vamsi. So you have good profile actually. I would say prepare a little bit more on, a little bit more on salary part. Like they might say, oh, what, private has more salary, government has a stagnant salary. What will you do like that? Rest, you have amazing
Mm.
technical. Your fluid mechanics, heat transfer is good.
Yes,
Obviously,
sir.
I couldn't cover each and everything, but yes. And you have good mechanics as well. Maybe next time we meet, I will go with SOM and thermodynamics as well. Okay?
Okay, sir.
Yeah.
Sir,
Meanwhile,
when can we
let's say maybe in a day or two, I will see.
okay,
Okay?
okay, sir.
Yeah.
Okay, sir.
Okay.
Okay, sir.
Tejeshwar, the meeting is ending, so please join in with the same link. Okay? And you two can join in as well. Uh,
Okay, sir.
Mahendra and
Okay, sir.
Shrikant. Okay, I'll be discussing some more questions as well. Okay. I was thinking
Okay,
to
sir.
extend this question even more, but okay, let's see. So please join
Yes,
in
sir.
with the
Yes,
same
sir.
link. I'm ending this
Okay, sir.
meeting. Yeah.